Okay, so this is 5-2, and we're doing a lot of the same things we were doing in 5-1, but we're adding some identities now. So we're adding these sum and difference formulas, which if you look at your identity sheet, that's what these formulas are right here, the sum and difference formulas, and those are going to help us with section 5-2. Now, before we jump into verifying, let's actually just practice using the sum and difference formulas. So it says find the exact value of sine of 15 degrees. Exact value means no calculator. Okay, so we need to use some angles that add up to 15 degrees, or subtract equals 15 degrees. So I could do 45 minus 30, or 60 minus 45, or 150 minus 135, but let's just keep it simple. I can use 45 minus 30. So using the sine difference formula, I'm going to use this formula right here, where A is 45 and B is 30. So this is my A and this is my B in that formula. So I have sine of 45 cosine of 30 minus sine of 30 cosine of 45. That's root 2 over 2 and root 3 over 2 minus 1/2 and root 2 over 2. And then I have root 6 over 4 minus root 2 over 4, and that's my exact value. Okay, let's move on to the next one. It says find the exact value of cosine 70 plus cosine 40 plus sine 70 sine 40. So what we need to do here is match up which formula is this. Well, if we have cosine cosine, sine sine with a plus in the middle, that's cosine cosine, sine sine with a plus in the middle. So cosine difference formula. So if this is A, this is B, A, B, this is cosine of A minus B, cosine of 70 minus 40, and that's going to be cosine of 30 degrees, which is root 3 over 2. Okay, not so bad. We can also use these identities in verifying. So if I have cosine of alpha minus beta, those are just Greek letters, they work the same way as any other variable. I can use that formula, and that'll be cosine of alpha cosine of beta minus or plus sine of alpha sine of beta over cosine of alpha cosine of beta. And from here we can separate these fractions. And this cancels and cancels, so we just have 1 plus, and this, because these are the same angle, can be tangent and tangent. So tangent of alpha, tangent of beta, and that's exactly what we wanted. Okay, so that's how we can use verifying with these sum and difference formulas. Let's go ahead and look at another one where we need to find the exact value, which again means no calculator. So if we want to find the exact value of 5 pi over 12, well, 5 pi over 12, we need to rewrite that as two angles added together that are angles that we know. So I could do 2 pi over 12 and 3 pi over 12, because that reduces to pi over 6, and that reduces to pi over 4, and we know both of those. So that would be sine of pi over 6 plus pi over 4. And using the identity, that's going to be sine of pi over 6 cosine of pi over 4 plus sine of pi over 4 cosine of pi over 6. And now we're just evaluating. This is 1/2. This is root 2 over 2 plus root 2 over 2 and root 3 over 2. So we got root 2 over 4 plus root 6 over 4. They won't always be the same numbers, but the ones we've looked at so far happen to be. Okay. So let's move on to the next page and do our next example. So it says, suppose that sine of alpha equals 4 over 5 in quadrant 2 for an angle alpha, and suppose sine of beta is 1/2 in quadrant 1. So we need to go ahead and find the following values. I'm going to draw some pictures for this, and I'm actually going to zoom out a little bit so we can see all of this. This is for alpha, and this is for beta. So alpha is in quadrant 2, and it says sine of alpha is 4 over 5. So drawing this picture here, 5 would be our hypotenuse, 4 would be the opposite. And then for beta, it says we're in quadrant 1, and this is beta, and it's 1 over 2 in quadrant 1. So 2 is the opposite, and sine is opposite over adjacent, so this is 1. Okay. Now we can use trig identity or a Pythagorean theorem to find these. So this is going to be root 3. And this is going to be -3 because we're on the negative x-axis. So I'll just zoom in really quick on those pictures here. So again, just using the information that they gave us, we used this right here for this picture, and then for beta we used this information right here. And now we need to find these exact values. So first let's find cosine. Well, cosine of alpha, if this is my setup here, alpha, we can use our reference angle, is going to be adjacent over hypotenuse. So cosine will be -3 over 5. Next one, cosine of beta. Well, now we're back in quadrant 1. We know it'll be positive. And cosine is going to be adjacent over hypotenuse, so we'll have root 3 over 2. Now we have sine of alpha, we have sine of beta, cosine of alpha, and cosine of beta. So now we can solve these as well. So it'll just be a matter of substituting things. So cosine of our sum here is going to be cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And cosine of alpha is -3 over 5. Cosine of beta is root 3 over 2 minus sine of alpha, which is 4 over 5, and sine of beta, which is 1/2. So that's going to be -3 root 3 over 10 minus 4 over 10, and you could either write this as a single fraction, or you could write -3 root 3 over 10 minus 2 over 5. Okay. Now for sine of alpha plus beta, the formula is different. Sine of alpha, cosine of beta. Plus sine beta, cosine alpha. And it's just a matter of substituting. And then we have 2 root 3 over 5 minus 3 over 10. Okay. One last example. Let's go ahead and verify this. So we have this trig identity here we want to verify. We're going to use the tangent difference formula. So tangent difference formula is right here. So that's a formula we're going to use. And this is my A and this is my B. And notice we have x and then pi over 4. So we'll be able to do some evaluating here. So we have tangent of x minus tangent of pi over 4 over 1 plus tangent of x tangent of pi over 4. Well, tangent of pi over 4 is 1, tangent of pi over 4 is 1, so we can substitute those in. We get tangent of x minus 1 over 1 plus tangent of x times 1, which is just tangent of x. Well, just switching the order of those things, that gives us our answer. And QED. We're done. And that is going to give us the end of section 5-2.